So hey, this is a photo of Srirangam Sri Ranganatha Swami Temple in Tamil Nadu. We're going to pass this image to Ollama Vision with Llama 3.2 Vision and ask it to describe this image. So here it goes. The image presents a breathtaking view of a large temple situated in the heart of a bustling city. Temple architecture. The temple's architecture is characterized by its grandeur and intricate design. It features multiple levels, with each level adorned with carvings and sculptures depicting various Hindu deities. This is absolutely amazing. I just passed this photo and it's able to give such an amazing description of this temple architecture right away. So my next photo is something really special to me. So I was fortunate to get a signed copy of linear algebra and its application by none other than Professor Gilbert Strang. And he also wrote a note. So we're going to ask Ollama what the note is. So this is what it says. The handwritten text reads, "To Lax, with best wishes, Gilbert Strang." The message appears to be a personal note or dedication, possibly written on the book's title page or inside the cover. The text expresses goodwill and appreciation from Gilbert Strang to someone named Lax. This is absolutely amazing. This is just what it was. And I am so happy to see that it's able to get it. Hey everyone. So welcome to the Lax AI channel. Hope you're all doing well. So today we're going to look into something really interesting in the world of vision AI models or vision language models, as they call it. So over the past few weeks, there have been quite a significant amount of updates in the VLMs areas, in the VLM space, starting from Llama's 3.2, Meta's Llama's 3.2 vision model. First, they had a 3.2 vision model, which is with 11 billion parameters, and very recently they also increased it to like 90 billion parameters. And then after that, there was also like a Pixtral model from Mistral, and this also was a really large model. And then quite recently, I think there was also Lava 01, which was trying to kind of reason with images and so on. There have also been a few other updates in the vision space, like DINO and then a few other things. But the amazing thing is that, at least from what I've seen, GPT-4o and GPT-4 images, those were the only ones which were really like great in the vision space for quite some time. That was the only model which was doing a really great description of images. I still feel that GPT-4o would still be really good in describing images and doing other activities on it. But it's great to see that just within a gap of like few weeks, we have many more vision models to kind of try. So today what we're going to look into is that so Llama's vision models are available in many places, and one of the places is called Ollama. Like Ollama is a software tool which you can download it to our machines, and this is mainly to run local models. You don't have to need any cloud access or other access to kind of do prompting or getting the queries and results and so on. Everything can be done locally. Hopefully, if your hardware is good enough. And Ollama also provides a large list of models that kind of you can download them to your machine and kind of also use those models. So today that's what we're going to see. We're going to see Llama Vision with Ollama all running locally. So let's jump right in. So first I wanted to show the Llama family of vision models that was recently recently got released. So here is the Llama's web page, as you can see here. is that Llama 3.2, the two largest models, and this is talking about the different Llama models out there. And also along with this was also the vision models that got released. So you can see that light revolutionizing edge AI with vision and open and customizable models, right? So first is Llama 3.2, and then the vision models. That's where it comes in, and they have some really interesting demos here. As you can see, Llama 3.2 model analyzes the image, showcases a modern. You can see the image is being uploaded, and it's able to describe this image very nicely. And it also says there's a couch, there's a chair, and so many other things. And also gives you suggestions to like replace and look up and things like that. So this is just an example of what, and then it also they coupled up with RAG so that the whole pipeline is like end to end with so many other options. So this is the interior design assistant they were showing with the Llama 3.2 model. So this is one part of just the Llama 3.2 vision models. But around the same time, what happened is that um, so Llama 3.2 Vision this was November 6th, was now available to run Ollama in both 11 billion and 90 billion sizes. So basically what this means is that you can run download Ollama here and then just run these commands. 3.2 Vision if you're running just the 11 billion version, and then also they also have providing the 90 billion version, which is like really large. And it says that for the 11 billion version, you need at least 8 gigabytes of RAM, and for the 90 billion versions, you need at least 64 gigabytes of, or not this RAM, VRAM, and for this one, you need 64 gigabytes of VRAM. I definitely do not have for the 64 gigabytes of VRAM, but I believe I do have the first one, so I am just running the 3.211 billion model for today. So here are some of the examples that they provide in their blog. So this is like handwriting, and then it can do OCR. Then it can also understand charts and image and so on. So what how it's so easy to also use. So what you basically you do is that first you install download Ollama, and it has an installer which will install it. So this itself was around like maybe like 750 megabytes or something like that. Then Ollama 3.2 Vision. When once inside the terminal, you just type Ollama pull 3.2 Vision. So this will actually like pull all the look like containers from what I saw, and kind of build the whole 3.2 Vision from inside Ollama. So they have to run this. They have a few options. One is just basically on the terminal. So this is in Mac, but it's also you can do the same thing with a PowerShell in Windows or a terminal in Linux. So and as you can see that you ask the questions, and kind of it does put it in a very nice way. It gives you the answers in a very nice way. And what you can also do a Python version if you want. Like you can see that import Ollama, and then you have a chat response. You have like you specified what the model is and what the role and the content is, and so on, and you'll be able to get a similar response from there. So that's where and one more interesting thing what I saw is that Llama 3.2 Vision is when they mentioned that it's available in both 11 billion and 13 billion, I mean 90 billion models. Even the 11 billion ones is actually like available in different quantized versions. So if you actually like go and see what they have here is that if I go and click on these 9 tags, so you can actually see that the latest is the 11 billion of Q4, the quantized 4-bit looks like. whereas it also has or this one rather it also has, and this one you can see that it's like 7.9 gigabytes, and then they also have like the 11 billion instruct FP16, which is like 21 14.16, which is like 21 gigabytes, and a quantized 8, which is like 12 gigabytes. So different models they have in between. So what they're actually providing is the smallest model, like the smallest quantized model. And similarly, they have like different sizes of the 90 billion also. But anyways, I'm not 90 billion won't run for me like with my computer. So you have like 95 gigabyte, 55 gigabyte, and 177, and this is the one that's default. So what we do is like we're going to I've downloaded all the models, and we're going to see how to use them on images, and then directly show pick a few use case, a few images, and see. So let's go. So hey, so what happens after you download the model is that you can open up a PowerShell, and in the PowerShell you can just so Ollama is now installed. First, what I'll do is I'll do Ollama list. What Ollama list will do is that it'll tell me what all models I have downloaded so far. So I downloaded the Ollama 3.2 Vision, that is the 11 billion Q4. And then also download the bigger one, the 21 gigabyte one, the Instruct FP16, floating point 16. So the only difference is this one is supposedly slightly more accurate than supposed to be than this, as you can see with the size difference, and the weights also will reflect to that. But this also takes a longer time to process, because more precision, and then it's also going to take more time. So we'll just stick to mostly this for now, to today, the 11 3.2 Q4 itself for all our things. So we saw one one hand. So what we do next is that you just say Ollama, I think run something else, right? Ollama, yeah. So basically you say Ollama run, and then the model name. Which model do you want to run? So previously what we did was we saw how it was recognizing handwriting from Gilbert Strang. And so this is another one. So this is a very, so my 5-year-old daughter, she goes to phonics classes. So she knows how the words are being like pronounced. So her imagination, with that imagination, what she did was she kind of wrote all that together. So as you can see, this reads like you have January, February, March, or say April, and all of that again. So what we're going to do is that we are going to pass this to Ollama, and let's see if it's able to find out. So I'll ask what is written in this image, right? And the very easy way of Ollama is that they made it so easy is that you just click here and then say copy the path. And once you copy the path, what you do is just paste the path here. So that's it, right? So I just not a child, so it first adds, and then it takes a while to kind of do the querying and answer. So you can see that it has January, February, it's also done. So this is what it says. January, February, March, April, May, June, July, August, September are visible on the chalkboard. Let's even ask, what can you say? Anything else about this image? So this kind of adds context. So the context also is kind of inbuilt. That's why I wanted to mention this. So it says the blackboard made with fabric green chalk writing. The board displayed what looks like a calendar of months, and it is likely that the person who created this board is learning how to write in another language or practicing their handwriting. So yeah, kind of somewhat something similar to that. So you can see, so it's even able to recognize June, July, August, and all of this kind of as what my daughter wrote. So switching gears, what we'll do next is that so we saw um, uh, handwriting, and then I also want to show one more photo. So we saw like Gilbert, we were able to identify like Gilbert Strang's handwriting there, right? So I was lucky to kind of be um, like uh, have a photo with Gilbert Strang, as you can see here. This was when I was a graduate student at University of California, Santa Barbara. So what I'm going to do is I don't think it will recognize because usually these models don't recognize people. What do you see in this image? Something like that, I'll ask. Um, I'll also try to kind of, this is the other image, but also try to see if ask it if it can actually like guess who the person is. ChatGPT usually does it, but let's see. So it says the image shows a man standing on the left side of the picture wearing a long sleeve button up shirt and standing next to a man wearing a t-shirt with a large white logo that reads "Enjoy California." That's nice. I'm actually wearing a almost the same similar t-shirt with on red color today. If you can see here in my camera, it also reads "Enjoy California." They're both smiling. So let's see this. So one of, and it says it's the real thing. So it does say it's the real thing. So it's also able to actually get this part where it says it's the real, it's something like that, real thing, right? So that's amazing. So the person in the left is a famous math professor in MIT who became whose videos on linear algebra became viral on YouTube. His course is called 18.06. Can you guess who he is? I doubt it'll guess because, but let's see. Right, maybe Gilbert Strang. Oh my God, that is amazing. So you see here why this um, why this is called a multimodal model, because it got the context from the image, but now when I ask a question which is text, it's answering based on its textual things, right? This has nothing to do with the image. I just prompted it and then asked directed it to the text. So it's built in not to identify the photos for some reason, but if I ask it to direct it to like still do it textually, it's able to like get it right there. So that is absolutely amazing. I think I'm so happy to actually like see that. So let's further switch gears. So hey, so what happens after you download the model is that you can open up a PowerShell, and in the PowerShell you can just so Ollama is now installed. First, what I'll do is I'll do Ollama list. What Ollama list will do is that it'll tell me what all models I have downloaded so far. So I downloaded the Ollama 3.2 Vision, that is the 11 billion Q4. And then also download the bigger one, the 21 gigabyte one, the Instruct FP16, floating point 16. So the only difference is this one is supposedly slightly more accurate than supposed to be than this, as you can see with the size difference, and the weights also will reflect to that. But this also takes a longer time to process as because more precision, and then it's also going to take more time. So we'll just stick to mostly this for now, to today, the 11 3.2 Q4 itself for all our things. So we saw one hand. So what we do next is that you just say Ollama, I think run, something else, right? Ollama, yeah. So basically you say Ollama run and then the model name. Which model do you want to run? So previously what we did was we saw how it was recognizing handwriting from Gilbert Strang. And so this is another one. So this is a very, so my 5-year-old daughter, she goes to phonics classes. So she knows how the words are being pronounced. So her imagination, with that imagination, what she did was she kind of wrote all that together. So um, as you can see, this reads like you have January, February, March, or say April, and all of that again. So what we're going to do is that we are going to pass this to Ollama, and let's see if it's able to find out. So I'll ask what is written in this image, right? And the very easy way of Ollama is that they made it so easy is that you just click here and then say copy the path. And once you copy the path, what you do is just paste the path here. So that's it, right? So I just not a child. So it first adds, and then it takes a while to kind of do the querying and answer. So you can see that it has January, February. It's also done. So this is what it says. January, February, March, April, May, June, July, August, September are visible on the chalkboard. Let's even ask, what can you say? Anything else about this image? So this kind of adds context. So the context also is kind of inbuilt. That's why I wanted to mention this. So it says the blackboard made with fabric, green chalk writing. The board displayed what looks like a calendar of months, and it is likely that the person who created this board is learning how to write in another language or practicing their handwriting. So yeah, kind of something similar to that. So it's even able to recognize June, July, August, and all of this kind of as what my daughter wrote. So switching gears, what we'll do next is that so we saw handwriting, and then I also wanted to show one more photo. So we saw Gilbert. We were able to identify Gilbert Strang's handwriting there, right? So I was lucky to kind of be um, like like have a photo with Gilbert Strang, as you can see here. This was when I was a graduate student at University of California, Santa Barbara. So what I'm going to do is I don't think it will recognize, because usually these models don't recognize people. What do you see in this image? Something like that I'll ask. I'll also try to kind of, this is the other image, but also try to see ask it if it can actually guess who the person is. ChatGPT usually does it, but let's see. So it says the image shows a man standing on the left side of the picture wearing a long sleeve button-up shirt, and standing next to a man wearing a t-shirt with a large white logo that reads "Enjoy California." That's nice. I'm actually wearing a almost the similar t-shirt on red color today. If you can see here in my camera, it also reads "Enjoy California." They're both smiling. So let's see this. So and it says it's the real thing. So it does say it's the real thing. So it's also able to actually get this part where it says it's something like that, real thing, right? So that's amazing. So the person in the left is a famous math professor in MIT who became whose videos on linear algebra became viral on YouTube. His course is called 18.06. Can you guess who he is? I doubt it'll guess because, but let's see. Right, maybe Gilbert Strang. Oh my God, that is amazing. So you see here why this um, is called a multimodal model, because it got the context from the image, but now when I ask a question which is text, it's answering based on its textual things, right? This has nothing to do with the image. I just prompted it and then asked directed it to the text. So it's built in not to identify the photos for some reason, but if I ask it to direct it to like still do it textually, it's able to like get it right there. So that is absolutely amazing. I think I'm so happy to actually see that. So let's further switch gears. So we're going to switch gears to something which is really interesting. So on surveillance and CCTV, the vision language models can have a huge use, real commercial applications, and so on. So what I'm going to do is that, so first let me show the picture. So this was a CCTV footage taken during two timestamps. So what you could see here is that it's a little tiny, but you can see that actually the right one is that something which happens first, and the left one is something which happens next. So you can see that this has an 8-camera system, and then a person is coming this side, and then this is in camera 1, and the same person reappears in camera 2 after a few seconds, basically. So we're going to see, first, let's see, let's ask it to describe what it sees, right? It's also a little low resolution, so let's not fully certain on what it can actually guess. So let's first see. What I'm going to do, as before, is I'm going to copy the path, and I'm going to say describe this image. So describe this image. So let's do here. So what I've also done is I actually have a more detailed prompt for this. So what I'm going to ask is, let me also copy that prompt. So what I'm going to say is that this is an image of 2 screenshots of a CCTV, and then copy this prompt here. So this is after we do this whole thing. It's basically like a student. Okay, the image is composed of 3 side-by-side photographs showing the same. Okay, so I think, I see what the problem is. So this should not be happening. So let me close this, and let me close this again. So what needs to be done here is, so what happens is that sometimes it kind of it gets confused with the image. So what you have to do is just end, at least from my, you have to end that and restart Ollama again. So you could also clear the variables and all of those things, but anyways, I feel this is a better, easier, cleaner way to do things. So now we have the pull down to describe this image. So hopefully now we should not have the same issues. So the image presents a collage of 3 security camera screens, each depicting displaying distinct views. The top left shows views the front door to a house, while the top right screen shows a view from the side of the same house and facing inward, and the bottom house a wide angle view of the driveway. So yeah, it's able to get some of the things right, but first of all, there are only like 2 views and not 3 views, so that's one thing which it got wrong. So let me also um, kind of I said I already have a prompt ready. Um, so let me see if it's able to actually even without me telling it. So it says that this is an image of 2 screenshots of a CCTV multi-camera system with 8 cameras taken at different timestamps. Starting from the top left, name the cameras as Cam 1, Cam 2 to Cam 8. There's a person appearing in Cam 2, which we saw before, and the same person also appears in the right. So can you kind of identify which camera the person is appearing and reflecting on your own answer and so on. So let's go back and see the, oh, okay, that was pretty fast. So let's go back and see, it's also, I think I also asked it to kind of have a JSON with the whole thing. So if you go back to this image, so Cam 2 is here and Cam 1 is here. So this is like you're asking it to, if you're assuming that I've given this as the Cam 2 as the one where the person is present, in the right timestamp, it should give the answer as Cam 1. So this is where usually like ChatGPT is pretty good at because it's something. So yeah, so see, this is what I expected. It's unable to kind of. So what it basically says is that I said the same person is appearing. It says I'm unable to identify the camera in which the person appears in the right timestamp. Therefore, I have not included it in my answer. So it's basically returning the same JSON again. So that's what it kind of says. And yeah, I think I did kind of expect this to an extent. So what I did was I have the same prompt, and I'm going to do it in ChatGPT, GPT 4.0, and I'm really hoping that this is going to nail it. So, well, it's giving, anyways, it's asking me, it's giving 2 answers, not even 1. So it says that the person appears in the top left camera in both timestamps. Based on the naming convention in the left timestamp, the person is seen in Cam 2, right? So that's what we said. We said that this is an image of 2 screenshots. There is a person appearing in Cam 2 in the left, and then we also said that the same person also appears in the right, and kind of tell me which camera the person appears in the right. Right, that's what we said. And look at what ChatGPT, GPT-4, and look how fast it also did it, right? It says that in the left timestamp, the person is in Cam 2, top middle camera, perfect. In the right timestamp, the person moves to Cam 1, top left camera, perfect. This is exactly what I was looking for. And this used to be a huge problem before, and it also asks me which response I prefer. I think I prefer this because yeah. Anyways, but this is called like re-identification. You can call it person re-identification, object re-identification, and this was like it's always been a huge problem statement in computer vision and AI, and I think with the vision language models and AI models. Things have become like it's going to get really much better now with these things. Like this is my old, like my graduate school vision research lab at UC Santa Barbara. It used to be a beach-facing lab, and we've had lots of my former colleagues used to work in this problem. You used to have a multi-camera network, and how can you re-identify people that are coming in different cameras and things like that, how things will change with respect to the domains and so on. I mean, like lots of students and lots of papers and thesis and so on. This is my work, so many of this is kind of here. But anyways, like this is amazing to see that the re-identification problem has actually like it's getting close to, like, you can call it either solved, or you can also call it like it's gotten much better now. Imagine you're like in a surveillance and setup. You just have this template, and you say that this is the person I need to kind of identify. And now if you have lots of different search spaces, these GPTs in like the vision language models can quickly also go and do the same thing, right? So that's how powerful like things have actually become. So interestingly, what also you could do is so let me see if I can have so there is this amazing Nvidia build, basically the NIMs. Anybody could go and explore these NIMs. And so if I go to NIMs here, I've been wanting to do a separate video on this. It's just too awesome. So if I go to NIMs here, and then if I need to like find the right model, which I'm not able to find visual. So visual computer vision. So I think in the top. Yeah, I think I got it now. So you have NV DINO 2 and NV grounding DINO, right? So, and the best part about these NIMs is that you could even try these models. They call it the experience. You could also try. Anybody could just try these models without even like actually like you don't even need an account, so you can just try these models. So let's see what it says here. So I'm going to upload this image, and I'm so getting uploaded, I think. And I'm going to say person, right? So, and I'm going to say run, and let's see what happens. So just for if I log in and if I have a personal account, they give like 1,000 credits. And if this is absolutely amazing, did you see here? It's identified the person and puts a bounding box here. It's identified the person and puts a bounding box here. So this is what we asked ChatGPT, right? It's said CAM2 and CAM1. And with grounding DINO, it's even more powerful when you kind of put these pipelines together. Like if you have the template, if you're looking for the person's template, what ChatGPT says, put these together, you get all of this kind of information so rich. So that's how powerful things are becoming. So I just thought I'll share this about the CCTV kind of analysis. So we're going to switch gears a little bit more. Pretty similar to surveillance and CCTV is another one which I call the, this is a pet project I'm trying to do, is the AI plant monitoring and AI kind of based plants monitoring of plants on a daily basis. So you can see that this actually is taken on different days, and this plant used to be really healthy. Unfortunately, you can see that progressively it's like becoming less and less kind of a thing. So what I'm going to ask is ask it to see if it can progressively, like what is the progression of the plant, something like that. So, and can you, if it can suggest any remedies. So first I'll run Ollama again. I will kind of I hope this time it won't get confused with the previous image. So I'm just going to ask what is the progression of the plant do you have any recommendations? So this is another area I think which has a lot of commercial value. So my vision is, or what I was envisioning here is the following. So I have lots of plants at home. This is a small for the AI plant-based project, plant monitoring. So the thing is that the idea is that I go and take photos of these plants on a daily basis, and I also timestamp them, and I track them on a daily basis. And then the idea is to feed these to a vision language model. And the vision language model is supposed to kind of analyze these and say that, okay, this is what is happening. So this is like a more of a pet and a small scale project. This was actually inspired by my by Venkateshwaran Kasirajan, who had an even bigger idea. He was one of the former persons who hired me and was for a different company. And so the thing is about this is that you're going to monitor these on a timely basis, on from time to time, right? And this is just visual sensors, but you can also have other sensors, soil sensors, any digital sensors, basically like the physical, the digital that you're kind of talking about. And what could be really, what I was hoping to envision is the following, right? If this, right now I go manually and take photos of this and want to see what it can do, and hoping that it will be able to do something really nice, then the future could be that you could send out drones. Instead of me manually taking photos, send out drones which go and take these photos. Or maybe if things go even like advance even better, like maybe send robots and take these photos and try to analyze them. Even further going to the future, right now this is still passive, right? You take those photos, you come back and you kind of analyze it, right? The robots could be equipped with it could basically know just by looking at the previous photos and the current day photos. It's like the Iron Man. It's like it can just kind of say what it is and then take the appropriate measures and so on. And then what about the ones like say trees and plants at higher areas? Maybe that's where the drones could be equipped with these robotic arms or some other fancy things, which would basically do the same thing. Like you'll have photos and videos being taken from time to time, and then you're kind of progressively monitoring this. So this, but one thing, if you see these, both the CCTV example and the plant example, is that these are taken at different times, and AI is kind of being asked to do some prediction or some other activity, right? And this actually is not just for this particular field. It has in healthcare. You have patient records on different times, or even monitoring of industrial elements, like you have factories and other things which can be monitored from time to time and so on. The higher level idea is monitoring and prediction and analytics, but the applications are so large in this, and both large language models and vision language models definitely have a big role to play here in this one. So let's see what this has said. It says that the progression of the plant appears to be growing and thriving with visible growth. That's actually not true. Based on the image, it seems the plant is receiving sunlight. So pruning if necessary, fertilization, repotting if the plant is going to contain. It's also important to know that. So unfortunately, this one is it's not done a good job. So I think maybe this is where again our ChatGPT would come to the rescue. So let me upload the same photo to ChatGPT, and this is where I think, I mean, again, given that this is a quantized model, which is really small. and 11 billion parameter model, which is also like quantized. ChatGPT, I'm guessing, is none of it has none of those issues. So what is the progression? I'll ask the same question. What is the progression of the plant? Do you have any recommendation? I'm pretty sure this is going to say that the plant is dying and maybe suggest some tips. So growth over time seems to be gradually spreading and increasing in leaf conditions. Some leaves looks healthy. Recommendations. Even this one is not actually saying the full thing. Soil quality looks dry in some images. Yeah. So can you identify the dates? So it is getting these right. And how is the plant in the middle progressing on these dates? Okay, now it's getting it perfectly. This is what I was talking before. Like it's saying that yellowing or drying of leaves is noticeable from stress factors. So first it says that it's green and new things are coming, and then it's kind of thing. And so some of the recommendations it's saying is like water, sunlight, pest treatment, and all of those. So this is what I was talking about, like SSD. Can you convert the above data to JSON? So this is the reason I'm asking is that this will kind of be able to like, if you want to like track it and programmatically like to build a program software on it, like this is the what it probably needs. So these are two applications at least I thought are really important. One is the CCTV and the other one is plant surveillance, which at least since I have access to both of these data, I could at least try how they work. So Llama Vision didn't work on both of them, but it's good to see that ChatGPT at least is able to like get at least some desired response from both. So let's switch gears. Hey everyone. So we're gonna come to the last part of this. So far, what we are doing was we were like putting all of this in the terminal, which is nice, but the problem with the terminal is that it's not always like if you want to build applications and then so on, it's not the best thing to do. And what Ollama, people have built UIs on top of Ollamas. There's a bunch of them in their GitHub. I think if I go to the Ollama GitHub page, you'll be able to see quite a lot of. First of all, it's like 99.5 stars, just a few away from 1 lakh or 100,000. And lots of people have built like UIs on top of that. Yeah, see, integration, open web UI is one of the most common ones. Then quite a lot of other ones also, just like a huge list. But the bare version which they provide is like terminal based. So I would like to like maybe look into some of these, but what I wanted to do is that so I saw this Python code snippet, right? Input Ollama response and then so on. So I copied this and then go to my favorite, one of my favorite, I alternate between ChatGPT and Claude. So I'm just going to say convert this to Streamlit code. And let's see what it does. So you can see that it's generating the Streamlit app. Convert first it kind of converts it to image to base 64, and then it also it's always good to just check, verify if things are okay, and then so you can say that it says what's in this image, and then it also gives you this. So you could also ask it um, if you want to do further customizations, you can ask it to do, and you'll be able to get more customizations as possible. So what I did was I already did this part, and then kind of made some customizations, and then kind of had my own server. So what I do is I'll just launch that. So once you kind of once you save this as a Python file, and you just go and say Streamlit, and assuming that you also install Streamlit in your virtual environment or in your Python, you just say Streamlit run Ollama Vision, whatever the file name was. And if you see, it's here. It's Ollama Vision chat. We have this kind of nice interface here. So let's just see if it works now. So what I'll do is let me pick a different folder. So I'm going to go to. So one thing I forgot to, or if I did not mention, is that these are smaller ones, meaning that I resized the image so that the response is fast. So this one, for example, this is 1200 by 1588, but the actual image would have been bigger. So I mean, this is not that small, but anyways, let's click on this, and I'm going to say instead of saying like what is in this image, I'm going to say count the number of objects, right? So let's see how well it does and then say get response. So let's see what it does. So let us count the number of objects. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 here. And so one thing I noticed is that the terminal is faster. Oh, there are 14 objects in this image. That is amazing. I was just about to say the terminal is faster, and then the Streamlit may be a little slow because it has to go put all those pipelines and the bindings together. But at least it was not as slow as I thought it was. So yeah, that's amazing. It did get it right. And then so yeah, the counting test also was a nice one. And let's try a few more different other cases. So count is, I just divided it into different categories. So the count is done, and let's try, I think I had charts. So this was one of my favorite ones. So what I did was so this is my own describe this image. I'm not going to go, it's just like chart, understanding the chart. So this is my own Google Scholar page. So so I wanted to see if it's able to get the trend, so what citations I have and what other kinds of things. So basically just understanding the chart. So a little bit of it is a chart, but a little bit of it is the understanding. In fact, I'm curious how this year would turn out, because I've not been actively publishing for the past 2-3 years or so. Till then, I used to publish a good amount of papers every year. But now I'm hoping to at least get back on that journey, and then publish more, hopefully, fingers crossed. So yeah, I think for this image, it's taking a little bit longer. But anyways, let's see what it's able to guess. So just a few more we wanted to try. So this, and then what we have here is puzzle. Do I have any puzzles? No. I guess there is a puzzle. Interesting. Let me click on this. So this is a very funny thing. So first, let me also rotate this so that it's the right kind of a thing. So is this rotated? Yep, it is rotated. So this is a magazine, Tamil magazine, and so basically it you have to find 6 differences between the two images. So I doubt it'll get that. So this one is still going on for some reason. So anyways, let's wait for that. I wonder why this one particular is a little slow. So let's try to find the 6 differences. For me, I've been doing this since I was a kid, but always, how many times I will do it, I forget at least 1 or 2. So let's start from this. I think like this one is here, this one is not here. That's 1, and then there is 2 here, and there is 3 here. That is 2, and then there is something here and something not here. There is 3. And then, so, oh yeah, the yellow and orange, that's 4. So we're getting close. Oh, he has a mustache and no mustache, 5. And always the sixth one is the one which kind of you keep missing. Okay, got it. So this red and this blue is the 6th. So not bad. So I'm hoping that by this time this is done. So yes, so the image represents a LinkedIn profile. Unfortunately, this is a Google Scholar profile. But I think since the LinkedIn, is it there anywhere? So anyways, it's not there. So a circular photo of the face, name and affiliation, that's me. And academic background is not specified. Okay. A graph displays the number of citations with a total of 3841 as of 2019. So that's really nice. It's able to kind of, just from the image, I mean, simple OCR, but it's able to like kind of do it. And 3841 since 2019, 19 articles and 23 papers, co-authored 23 papers. And then, well, it says their H index is not specified, but actually it is specified, I think, here. So I wonder why it kind of mentioned that it missed that, like it is specified here. So this one, it kind of got it okay, and it didn't tell much about these things. So, and I think like it also messed a little between, since 2019 is actually 3163. It says with a total of 3841 as of 2019, which is not correct. So it tried to understand this, but not perfect. So, but yeah, like it is good to know that that's one thing which it did. So then let's try another one. Let's go to the puzzles. I really doubt if it will be able to solve this, given that it's not able to solve other things. But let's give it a try. This image has two photos. In that, each of them, there are six differences. Can you the 6 differences? So this is going to let me copy the prompt because I also want to try this with ChatGPT. So let's give it a try. Where is ChatGPT? So this is where it'll be interesting to see what ChatGPT also says for this. I don't know honestly if ChatGPT will get it, but I have a strong feeling it may. So let me go here and puzzle. So this magazine is called Kumudam, by the way, if anybody's interested. So let's see what it says. One thing is I know is that ChatGPT is pretty fast, so it's let's see if this one is, yeah, so this one is still processing, so it's going to take quite some time. I've opened the image for review. Let me closely inspect and help you identify the 6 differences. The symbol on the microphone, so that one, it got it right. We can see, well, it's not the microphone in the top image, okay, but it's something else. coins on the table. So that is not true. So the parrot's cage, designer contains, okay, this is true. The cloth on the table, there's a difference in pattern on the design of the cloth, which is not true again. The person's expression, subtle changes, nope, that's not true. It's just the mustache. Background detail, element details, elements in the background of the tree are object different. Nope, not at all. It's so that's pretty. I think this is where if you want to do those kinds of Turing tests and all the other kinds of tests, where humans are at least like you could easily spot these, and then this one it's not even getting most of it right. So if ChatGPT is performing this way, I'm not that hopeful from Ollama, but let's see it anyways. The flipped image, text positioning, background color, object positioning, character. I think it's even worse. At least ChatGPT tried to at least get the context, but this one has gone way beyond. But yeah, these. It's also good to know that these are some of the limitations, and that's where the more work could be done in future. So I think there's just one more thing I wanted to do, the translation part, but I think let's maybe wrap this for today. So hey, so we saw what vision language models and AI vision models are capable of. And then what's amazing is that tools like Ollama, they allow you to kind of download the models to our own computer, and kind of we're able to do all of this without even needing to pay anything to like ChatGPT or others, and also many of the basic things where it was able to get it right. So this, and you could also, and finally we also saw that by there are so many options if you want to build UI and apps, and then also like Python bindings and things like that. So what will be interesting to see is how these models are going to kind of keep getting better and trying to advance the fields more and more. And as I mentioned before, this is just one model that came out in the past few weeks. This itself has so we are looking. What I tried today is the Llama 3.2 11 billion, and the smallest of that, the most quantized version of that. But what is available actually is the Llama 90 billion instruct, and imagine the least quantized version trying that out. So that is what will be like really interesting to kind of try. Maybe that's something which I hope to try very soon. And then again, like I mentioned, Pixtral has come out with again a very large model, Pixtral large. And then Llama 01 has also come out recently, and I think even Quen had something, if I remember correctly. So it's great to see that there are so many of these coming in and advancing many of these things here. So finally, what I would like to show is that this is the book, Linear Algebra and its Applications, Gilbert Strang, and I'm going to open the page, what I showed in the picture. So it's lucky to be kind of have a signed copy from Gilbert Strang himself. So as you can see here, Linear Algebra and its applications, with best wishes from Gilbert Strang. So I'll end with that. All right, until next time.